We are maximizing utility subject to a budget constraint, and this is the normal situation. Let's imagine you're trying to figure out the optimal consumption bundle, the optimal mix of peanut butter and jelly to put on your peanut butter and jelly sandwich. We have our preference map with our 3 indifference curves that represent levels of utility, U1, U2, U3. As you go up and to the right, you gain more utility. The standard way to approach this is we compare point A and compare point B, where the dotted line is our budget constraint. So we can't go above our budget constraint, and the goal is to find the point on this preference map that maximizes utility subject to that budget constraint. Well, point A is going to exhaust the budget. It's going to use up all your money. It's going to land you on U1. But you could climb to a higher position on this mountain of utility by altering the mix of peanut butter and jelly on your sandwich by having a little less peanut butter, a little bit more jelly, and moving along the budget constraint to point B and reach a higher indifference curve. That's our standard model of preferences and our standard way of finding an optimum consumption bundle. But there are exceptions to this standard model that are very important for helping us understand how utility maximization works, how human beings tend to operate when they're trying to make decisions about what they're going to consume. This is the standard way of looking at it. The marginal rate of substitution, which is the slope of an indifference curve, will be equal to the slope of the budget constraint when utility is maximized, meaning that the budget constraint will be tangent to the indifference curve. When two lines are tangent, they have the same slope. Or when a line is tangent to a curve, the slope of the curve at that point is equal to the tangent line. And in a previous video, I showed you some exceptions to our standard indifference curve. And here's a situation where we have perfect substitutes. We have 2 different cows. Say maybe you got 2 different cuts of meat off the same cow, a New York strip versus a ribeye or something like that. And with perfect substitutes, the indifference curves are straight lines. So U1 and U2 are straight lines. The dotted line again is our budget constraint. And if you compare point A to point B, both A and B are on the budget constraint. So we're spending all the money. The consumer will exhaust their budget. If you look at point A and point B, you can see that point A is on a lower indifference curve. This individual can switch from one cut of steak to a different cut of steak and get to a higher indifference curve. And so what ends up happening with perfect substitutes is the budget, or rather the slope of that budget constraint, is going to dictate what you actually end up consuming. Here's another example. This time it's the same indifference curves. I've just changed the slope of the budget constraint. I've made one of them cheaper relative to the other. And now we see that point A is the point that's going to give us the most utility. We can make it up to U2 by shifting up to point A. And with things like perfect substitutes, what you'll notice is the optimum consumption bundle is not in the middle of the graph somewhere, it's along the edge. We call this a corner solution. So with perfect substitutes, basically what's going to happen is the consumer is going to pick the one with the lowest price and end up again on the edge of the graph. And instead of calling it an edge solution, we call it a corner solution. Let's talk about complements. Complements are things that you consume together, and perfect complements tend to be consumed in a fixed ratio. Let me show you what I mean. So here's the perfect complements indifference curves. And if you compare point A to point B, both are on the budget constraint, therefore exhausting the budget constraint. A is on U1. So by shifting the mix of surf and turf of lobster to steak and adding a little bit more steak to the plate and pulling some lobster off, the individual can jump up to indifference curve U2 and reach a higher level of satisfaction. And what ends up happening with these types of indifference curves, in this example here, the budget constraint is fanning out because the steak is getting cheaper. And as the steak gets cheaper, you'll notice the consumer is going to be consuming more of both goods. Very common thing we see with complements because they're consumed together. What ends up happening with these things is you get what's called a linear expansion path where the person wants to consume in a fixed ratio. So it's always a 1-to-1 ratio or a 1-to-2 ratio or a 1-to-3 ratio. And if you're thinking about maybe Sheldon Cooper from the Big Bang Theory, who might have a very specific set of preferences, I've got to have this amount of peanut butter and this amount of jelly exactly in this ratio. Not necessarily. Maybe it's something like a precise recipe, or too much of one ingredient ruins the bread you're trying to bake. This is an example of someone who might have a shellfish allergy. This individual gets no utility Or rather, utility doesn't increase when they consume lobster. They want to move to the right to increase utility. And so if you look at point A and point B, between point A and B, this consumer is going to choose point B. Well, why is that? Well, because point B has less lobster, and more lobster doesn't help this individual. But if you're really looking at this and thinking critically, at point B, the individual is consuming some lobster. Well, if you don't like lobster, why would you spend your money on lobster? Or if lobster causes anaphylactic shock, why would you spend money on lobster? Well, you probably wouldn't. So point B isn't actually a good idea. What you would do is you would go to where U3 hits the budget constraint, another corner solution, and you wouldn't buy any lobster with your money and you would just eat the steak.